We want to differentiate this function, and we need to write it first in the correct form. So the square root of x, we should know, is x to the power of half, and 1 over the square root of x, we should know, is x to the power minus a half. Note we haven't differentiated, so it's still y. Only when we differentiate do we get the gradient function dy dx. The half drops down in front, and we reduce the power by 1. A half take away 1 is minus a half. Same here, minus half drops down in front, the minus minus makes this a plus, and then reduce the power by 1, giving us minus 1.5 or minus 3 over 2 as a top-heavy fraction. We might want to tidy this into this sort of form. So x to the minus half we know is 1 over root x, so we're going to get 1 over 2 root x. And for this expression the 1 will stay on top, 2 on the bottom, and to move the x to the bottom we get x to the 3 over 2, the minus disappears. This one stays the same, and then tidying here, the 2 on the bottom means it's a square root, and the 3 here means x cubed. Now considering this function, the first thing we need to do is expand the bracket. So to expand the bracket I'm going to use a grid. And we get 2x and minus 3, 2x and minus 3. This gives me 4x squared, minus 6x, minus 6x, plus 9. So this is 4x squared, minus 12x, plus 9. And of course we haven't differentiated, so this is still y. But now we differentiate to get dy dx. 2 drops down in front, we get 8, x, reduce the power by 1, this becomes minus 12, and of course the constant term disappears.